homework questions, and so I thought that would be nice. Mr. Gardner said she called Zane Yon, but apparently he meant Zane Crosby. We're talking about it right now, and she's probably watching this. Feel better, Emily.
Hi, Emily. Hello.
This is my awesome drawing skills here.
That's it, you failed. You failed the volleyball team. You're awesome volleyball team.
All right, so let's pay attention here. Number 18. Number 18 says, a square is inscribed in a circle. That's what this means. Inscribed in a circle means that the corners of the square touch the circle. Write the area of a square as a function of the radius. So step 1, how do you write area of a square? Mason, C. Length times width, but in a square, they're the same, right? So can I call both of those S? So I'm going to call that side squared. Aaron, are you ready? Aaron. Okay. Well, other people need to listen. So the area of a square is side squared, but we want to write the area in terms of the radius. So we want to replace S with R. So we have to think about how can we draw the radius in here. So the radius of the circle, like from the center, we could draw it straight down, but that's not going to help us because that's not going to help us with the side, right? It's going to kind of cut right through it. But could I draw the radius over like this? I think that's the radius. And there's lots of other, there's lots of ways we could do this. Like we could drop a height down here and make Pythagorean theorem. I like the idea of going on this side too. That would also be R. Do you agree with that?
I was really confused on why you wanted us to Pythagorean because I never used it. That's fine.
That would work, and we could make this big triangle here. Do you agree with that?
Yeah.
You could have also dropped the radius this way and made a triangle like that. Both of those would work, but I'm going to go this way. Could I set up Pythagorean theorem relating R and S to each other? Yeah, because I could say S squared plus S squared, those are the two legs, is equal to what? Right, R plus R is 2R, so this would be 2R squared, which would be the same as 4R squared. Do you agree with that? And again, there's other ways you could set this up, but you should be doing Pythagorean theorem somewhere. And over here, S squared plus S squared is 2S squared. You with me still? And now the goal is we want to replace S squared in terms of R. So could I just divide by 2 over here? And get S squared equals 2R squared. And I could take the square root and solve for S, but I don't need to, because I just need to plug in, if S squared equals this, that means the area of my square in terms of the radius is going to be 2 times the radius squared. But that was why you needed Pythagorean theorem. That's a good question, right? That's some good geometry. What other questions do we have? 36. How many times did you call Rosoma last night?
I still didn't get 33. I got 36. Yeah, I got 36. I didn't get 30. I didn't get 30.
Yeah, because the answer is write the area of the square. So the area of the square in terms of R, that's your answer. We don't know what the R is. 36 says, Renee's decorating service recommends putting a border around the top of the 4 walls in a dining room that is 3 feet longer than it is wide. So it's just kind of like a rectangle, right? I'm not going to draw 3-dimensional walls here. But those will be like my 4 walls in my dining room. And if it is 3 feet longer than it is wide, could I say that the width is W and the length would be W plus 3? 3 feet longer than it is wide?
I just guessed.
But I believe the directions want you to write an equation for the problem. you got the answer, but you missed the equation part. Find the dimensions of the room if the total length of the border is 54 feet. If we're talking about the length of a border going around the room, what are we talking about? Area of the room? Perimeter, right? Because we're going to put that border all the way around. So perimeter you can think of with a rectangle is 2L plus 2W, or perimeter is just adding up all the sides. Do you agree with that? Just to add up all the sides and set it equal to 54. W plus W plus 3 plus W plus W plus 3 equals 54. Or you could say 2 times W plus 3 plus 2 times W equals 54. And when you solve that, you get W, plug that back in, or just add 3 to it, and you get your length. I'm going to let you solve that out. That's not so bad to do, right? What about 30? Did you get number 30?
Yeah, man.
What did you get?
I got 16.3 or yeah,
I think it should be 16.
Yeah, I called it home on this one.
yeah, that
I called it home on all of them.
I just thought number 30% increase, you do that back in Algebra 1, but that's a long time ago. But you have to take the difference between the two values divided by the original value. And that equals your number. If you wanted to make it to a percent, I think you'd even say like equals x over 100. But you got to subtract those two values divided by the original value. Yeah. Like, because if you subtract the two, you get the difference divided by the original, and that would equal your x as a decimal if you want to make it a percent. Right. That's why you didn't get the right answer. Okay, you have a question, or are you just thinking back there?
No.
Right, you got to subtract the two. And so that's something that's an Algebra 1 thing that you do, percent increase and percent decrease, but it's been a while, so that's why I thought we could do this. On your test, the story problems I give you, like, maybe something about, salary increase or decrease, or maybe a geometric thing, like number 36, you should be able to do a problem with perimeter or area of a rectangle or area of a circle. But like 18, I probably wouldn't give you something like 18. Or a percent increase, I wouldn't give you something like that on your test. But it's good to remind ourselves of all the math we know. Okay? Is that pretty good homework questions?
Yeah.
Oh, I love 33. It's my favorite problem. A square of side x inches is cut out of each corner of a 10-inch by 18-inch piece of cardboard, and the sides are folded up to form an open-top box, right? Here's my visual aid. If I cut out a little square, pretend these are all going to be the same size. Right? If you have a piece of cardboard and you cut out a little square from each side, the same length square, and you fold up all the sides. Oh, that didn't work out so well. You see how you went from a flat piece of paper to a little rectangular box, and if this was cardboard, it would be much sturdier. We could carry things in, right? Yes, that's what number 33 is asking you to do. So a square of side x inches. Oh, it's a square even. Huh? Does it say square? How's it a square, but each corner of a 10-inch by 18-inch? Oh, a square. The square's cut out. Whew. I was having to move it. The square is what's cut out of it. So 10-inch by 18-inch piece of cardboard, and we're going to cut a square of x by x out of each one. X by x. X by x. And then it's folded up. So think about that normally 18-inch side is not 18 inches anymore because I've cut a little piece out of each corner of it. Right? I cut x out of each one. So write the volume as a function of x. Well, first of all, how do you find the volume of something like this, a rectangular prism? So the length was normally 18, but I took x and x out of each end. So how much is the length now? 18 minus 2x. Because minus x and minus x makes minus 2x. And the width was normally 10 inches, but I took x out of each end, so now the width is 10 minus 2x. And how tall is my little rectangular prism that I've made? X, because if you fold it up, it's going to go up as high as you cut out that little square. So my height is x. Part B says find the domain of your function taking into account the restrictions that the model imposes in x. So, that's part A. Part B is domain. So we want to think about what is the biggest square that I could cut out of this that would still be able to fold up into a box, theoretically speaking. What do you think? Could I cut an x of 2 inches out of each side? Because if I took 2 and 2 away, that would just be taking 4 away, right? Right, because if I took 2 inches from this side and 2 inches from this side, I'd still have something left, right? You have to have something left to be your other sides, right? So what can't I take out of it? Yeah, if I take 5 inches from each side, there's nothing left to fold up, so that's no longer going to make a box. And so this is one where the domain, you have to think about what you're actually doing in a real life situation. And we would say, I can't take 5 out. So we're going to say everything up to 5, that's going to be kind of a weird looking box. But I think 5 is our upper bound, not included, because I can't take 5 out or I wouldn't have a side left to fold up. I heard someone say we can't take a negative side out. That's true. We can't take negative out. Included or not included? Right. We can't take 0 out either, because if we took 0 out, we wouldn't have anything to fold up. Like, it would just still be a flat piece of paper. You couldn't fold anything up. But theoretically, we could pick, like, the smallest number bigger than 0, which, you know, you could just keep getting smaller and smaller. And it would just be a very, very, very small little fold, but not including 0. So that's your domain. So sometimes domain, you have to think about the real life situation that you're doing from 0 to 5. And then I told you didn't have to do part C because it says use your graphic calculator. Chapter 2, we're going to talk about solving this again, right? But they say use your graphic calculator to determine the dimensions of the cutout squares that will produce a box of maximum volume. Chapter 2, we'd actually solve this without our graphic calculators because we could multiply this all out, and then we'll talk about solving it and how exciting that will be, but you didn't have to solve this one. But the answer is approximately 2.06 inches is what we'd want to cut out of each corner to make the maximum volume. So that's kind of like some calculus there, because in calculus, you know, you talk about how could you make the maximum volume but for the least amount of money, right? So you want to use the least amount of material to make the maximum product, or the maximum volume. So when you go to the store and you buy stuff in a package, the way they make those packages isn't just, you know, random. They try to use the least amount of material but hold it the most stuff. So there you go. That's some good stuff. Okay? I think I just did like half your homework, but pretty close. We have a test tomorrow, so we better talk about it. So our first real test, our chapter P test was only out of 60 points. This is our first test out of 100 points, and you do get your midterms today. So after we have our chapter 1 test, you'll be able to get a new grade. But I just want to kind of go over the basic stuff that I want you to make sure that you know how to do for the test. And I make this review out after I make the test. So if it's on here, then you need to make sure you know how to do it for the test tomorrow. It's been a while, but at the very beginning of this chapter, there were some questions thrown in about solving equations with square roots. And people always forget that when we get to the test because it's been so long. But make sure you remember, like, you have to get the square root by itself, and then you square both sides. But most important, you have to check your answers, right? So, like, I'm just going to make this up. I'm not really going to solve it all out. But I could give you something like this. It's really ugly. But I could give you something like that to solve, You gotta move the 4 over first before you square both sides, and then to get rid of the square root, we square both sides, you get plus or minus, you get 2 answers, but remember that you have to check your answers, because sometimes you get an answer that when you plug it back in, it's an imaginary number, and I'm checking tomorrow to see, do you know how to check your answers? So, hint, hint, check your answers. Horizontal line test, vertical line test, that was section 1.5. Give you a few graphs tomorrow and ask you to tell me, like, is it a function, is it one-to-one? Remember, is it a function? That means it passes the vertical line test. All the x's are different. Is it one-to-one? One-to-one is like a new vocab word. That means it passes both the vertical and the horizontal line test, and it means that the inverse is also a function. So I'm just going to put vertical and horizontal line test. And we wrote out the definition of that in our notes in section 1.5. Right, so on the test tomorrow, I will not tell you what one-to-one means. You got to know. Domain and range, we've been kind of working on it all chapter. I hope it's getting better for you. Remember that domain is what the x's can be. So if you can think about what it can't be, if you see a square root, you can't have a negative under your square root. If you see an x in the denominator, you can't have an x in the denominator. But most of our functions have a domain of all real numbers. And maybe go back and look at your 10 basic functions and look at their domains. The range is the y values. So remember, think about, like, where's it going to start. Use your domain to help you do that. But remember, you can have a domain and range of all real numbers. So don't, like, I feel like that's the one people miss the most, is if I gave you a lovely little polynomial function, the domain's all real numbers, but people freak out about it. So definitely make sure you look over those tonight. Even, odd, or neither. It's been a while since we've done that, but I definitely have that on your test tomorrow. Remember, like, there's a test to do for this, and it's all about that you plug in negative x into your problem. If it's even, when you plug in negative x, nothing changes, right? That means it's an even function, because the negative doesn't change it, like x squared. If it's odd, that means when I plug in a negative, the entire thing changes. Like, you could factor a negative out front, and then everything would be the same. If it's neither one of those, like it's somewhere in between that, then we say that it's neither. And you're just going to have a few questions that the directions say, is it even, odd, or neither? And that's kind of what I'm looking for on that. You could graph it. Even means it's symmetric about the y-axis. But I feel like this is a better way of doing odd is symmetric in the origin. That's kind of weird. Yes, that's kind of a nice way to think about it. Even like nothing changes, right? Right, because like you get back to the exact same thing. When you plug in a negative, nothing changes. So even nothing changes, odd, everything changes sign. Right, like something changes, but something else doesn't change. That's another way to think about it. Asymptotes, that also helps with domain and range. Remember, vertical asymptotes, you just set the denominator equal to 0. It's also how you find your domain. Whatever your asymptotes are, your domain can't be if you have something in the denominator. But horizontal asymptotes, it's been a while since we did this. But remember, there are those rules about the degree of the numerator and the degree of the denominator. You got to know those by tomorrow. And I'm just going to use n and d for my numerator and denominator. But if the degree of the numerator is smaller than the denominator, remember that your asymptote is y equals 0. If the degree of the numerator is bigger than the denominator, there is no horizontal asymptote. And if the numerator degree is equal to the denominator degree, you have to take the leading coefficients over each other. We spent a few days on that. We did a worksheet over that where you had to graph and tell me the horizontal and the vertical asymptotes. Knowing how to do those is really important. Those 10 basic functions, I'm not really going to have you do a whole lot with them, except for you have to graph some stuff. So if you know those 10 basic functions and you know what they look like, You know the shape of a parabola. You know where a square root function starts. You know absolute value is a v, right? Like you should just be able to look over those tonight and test yourself. If I see a square root function, do I know that it's half of a parabola? You know, the logistics not going to be on there. E and ln, if it was on there, it would be like a matching question. But like those other ones, like absolute value, square root, squared, cubic, the ones that we've really been graphing in class. Sure. Okay. No logistic, unless it was a matching, which I don't think there is any on there. Like I feel like I can say 100% logistic is not on there. Add, subtract, multiply, and divide functions and domains that go with that. That was, I don't even know what section now. 1, I don't know. 1.5, 1.6, I don't know. I can't remember now. 1.5. Remember adding, subtracting, and multiplying, dividing. If you can put them together, you put them together. But a lot of times you can't even combine like terms, so it's not really that much stuff to do. But the domain, you have to take into consideration what the original domains were. Function composition, I definitely want to know that you can do that. F of g of x. Right, you're taking one function and plugging it into the other function. Maybe even doing that with some numbers like we did. Implicit, that was what was on the worksheet yesterday that you asked about. That's where it just says solve the implicit equation. You got to know that means solve for y. That's like the x squared plus y squared equals 16 question. And all you do is you solve it and you make it into two square root equations. So you would get like y squared equals 16 minus x squared, y equals plus or minus the square root of 16 minus x squared. Nothing else. Don't break any math laws. Don't break up addition, subtraction under radical. And we've done a lot of stuff. Yes? Because you can't break up addition, subtraction. You can't. The square root of x squared plus y squared does not equal x plus y. Like, it's just not true. Think about the square root of 3 squared plus 4 squared. That does not equal 3 plus 4. Because that's 9 plus 16. Yeah, that's not going to equal 3 plus 4. Like, it's just not true. So you can't break it up. Parametric equations. We did that numbers 1 through 6. The question on your test is going to be like 5 and 6, where you have to make an XYT chart given values. You have to graph it, and you have to eliminate the parameter. So remember, the big thing I think you got to remember is eliminate the parameter means get rid of t, right? So you're going to write an equation without t in it. Without t. So you solve one for t and you plug it in the other one. It's kind of some substitution. Usually eliminating the parameter helps you check to see if your graph is right. Because if you eliminate the parameter and you get x squared in your problem, then you know your graph should be a parabola. If you eliminate the parameter and you get just a lovely linear equation, then you know your graph should be a line. But make sure that you maybe kind of look over those. We're almost done. Oh my gosh. Okay, I'm going to show all these. Inverses, show and find. The book wants you to do the f of g of x to show that two functions are inverses. Colin really likes to just find the inverse of one and show that it equals the other. But the find, remember that means switch x and y, then solve back for y. You're definitely going to have some graphing on your homework, your test, knowing the shifts, the stretches, the shrinks, the reflections. But you're also going to have questions on your test tomorrow where I give you two graphs and I say, like, how did this change? Or I give you two equations and I say, how did this change? And it's like the one on the homework quiz. Like, I want you to say, it moved left 3 and reflected over the x-axis or something like that. So you want to make sure you actually know those rules. Graphing, you can always use a XY chart to help you graph. And story problems, don't stress too much about that. If you feel pretty good about last night's homework, there were some crazy ones on there, but just read the problem, set up an equation, and solve it. Like the story problems, I feel like are not the big part of this. So I have a review out of your book to do, hopefully to kind of help you remember all this stuff, because it has been a while. Remember that all of your homework chapter 1 is due tomorrow. That includes this review. So you should have a good amount of assignments done already, and then you're just going to add this review to it. Odd answers are in the back. I cannot stress enough how much you should be checking your odd answers to make sure you're doing these right. I'm going to kind of look over the homework really quick and make sure I agree with all the directions on this. The beginning ones are just matching graphs with equations, which will be really easy compared to that first day. Remember that first day, how awesome that was? So I think I did these right. 1 through 3, 5, 7 through 10, 20, 22, yeah, that's not graphing, 37, 37 and 39 say to graph, but you do not have to graph, so let's write that on there. Don't graph. It's just even odd or neither, so you don't have to graph those. 41, 44, 45 through 49, 53 through 56. Yeah, that's pretty good. So there's a couple little graphing ones, but I think that they'll be okay to do without a graph calculator, but a lot of it is just matching. So you have the rest of the time to work today, so make sure that you're working. You might want to